Hello friends and welcome to this tutorial. Here we will be discussing about few of the properties of natural numbers, whole numbers, integers and rational numbers. So we have all these properties on this table. We have the closure property, commutative property, associative property and distributivity of multiplication over addition and subtraction and properties of identity. So we have the natural numbers, whole numbers, integers and rational numbers. So to understand this property, let's understand the properties individually. So when we say the closure property, it means that if you perform any operations on a particular collection of number, the result will be of the same collection. For example, if you add integers, the result will be an integer. If you multiply integers, the result will also be an integer. If you subtract integers, then the answer will also be an integer. But if you divide integers, the answer may not be an integer. So that is why D is not written here. So we see that natural number and whole number are closed under addition and multiplication, but they are not closed under subtraction and division. So that is why S and D is not written here. And rational number are closed in all the four operations. The second property, which is the commutative property, means that you can perform any operations in any order. For example, when you are adding three numbers A, B, C, you can add them in any order. Or if you are multiplying three numbers, you can multiply them in any order. So we see that all the natural numbers, whole numbers, integers and rational numbers, they are only commutative under addition and multiplication, not under subtraction and division. Under subtraction and division, you cannot change the order in which you perform subtraction and division. So understand the property first, because the table is very simple. All these properties are under addition and multiplication. They are not under subtraction and division, except for the closure property here. Okay, so this table is very easy to remember, but you have to understand the properties. Okay, so now let's see how this commutative property helps us. For example, if we take these two examples of addition, okay, here three numbers are added. Okay, so if you apply commutative property here, so instead of adding this and this first, we'll add this and this first. Why? Because adding this and this will result in a much simpler value, and then we can add this number to that so that we can get the answer quickly. Now in this example again here, say 62 and 38. Okay, so we'll add this and this together first, and this together, 53 and 47 here. So this and this will result in 3500, and this will result in 1100. So the total sum is 3600. Now let's take an example of multiplication. So instead of multiplying this and this, we'll multiply this and this first. So 2 into 50 will be 100, and then we'll multiply this with 100, so that we'll get the answer this. So see how we have used commas here. Alright, so using this property again, the multiplication became easier, right? In this example, we'll multiply this and this first, and multiplying it then to this number, so that we'll reach the answer. So we saw how using this property, addition and multiplication became easier. Now let's see the third property, which is the associative property. So in associative property means you can group any way you want. This is also very much similar to commutative property, but here you'll be using brackets. Alright, so here brackets means first this operation will be done, then this operation will be done. But using the associative property, we can add this first using the brackets and then this. It is very much similar to the commutative property. Let's see an example here. So here in this expression we have 14 plus 17 together, but we can also write 14 plus 6 together and then plus 17, so that we have this as 20 plus 17, we'll get the answer 37. Here again we could have written 12 as 6 into 12 into 35. Then it is easier to multiply 2 and 35 like this here. You'll get 70, and then 70 into 6 will be 420. So yes, this associative and commutative both are very similar, but you saw what we did here in associative, right? We grouped the number as we wanted. And again, all these numbers are associative under addition and multiplication only. Now the fourth property, distributive over multiplication and subtraction, means, so if you have an expression like this where a is multiplied over the sum of or the addition of two numbers, that is why multiplication over addition. This is multiplication over addition. So we can write this expression as a into b plus a into c. The first number is being multiplied by the second number, and then again the first number is being multiplied by the third number, and then they are added together. Similarly, the multiplication over subtraction would be this multiplication over subtraction of two numbers. So again we can multiply the first number and the second number, and the first number and the third number, and then subtract each other. Now let's take this example. Here we have this expression where these three numbers have been multiplied and then added with these three numbers which are again multiplied. Now this can be written as 769 into 5, and 25 can be written as 5 into 5. Right. Now we can take 769 as common and these two 5 as common. So this term will be 782, then plus sign, then 218. So this is one product and this is one addition. So the addition of this will result in 1000. So we have to just multiply this and 1000. So you can directly multiply this. So 5 into 5 will be 25. We'll write 5 and 2 is carry forward. 5 into 4 is 20 plus the 2 which was carry forward. So 22. We'll write 2 here and 2 is carry forward. 5 into 8 is 40 plus 2 which was carry forwarded. So 42. So we'll write 2 and 4 is carried forward. The 5 into 3 is 15. 15 plus 4 which was carried forward, 19. So we have to multiply 19 into 1000. The answer will be this. Alternatively, we could have again broken down this as 4000 minus 155, right? So now using the multiplication over subtraction, 5 into 4000 minus 5 into 155, right? Now this 5 into 4000 will be 20,000. Again 155 can be broken down as 150 plus 5. Now here we'll use multiplication over addition. So we'll have 5 into 150 which is 750 plus 5 into 5 which is 25. So the summation here will be 775 which is subtracted from 20,000. So we'll get 19,225 which is then multiplied by 1000. So we'll get the answer this. So we saw how we used this distributivity of multiplication over addition and subtraction here. Now the identity properties. Now we say that a number is an identity if the value does not change for that operation. So we say that 0 is the additive identity because if you add 0, the value does not change, right? And even if you subtract 0 from something, the value does not change. So we say that 0 is the additive identity and 1 is the multiplicative identity, because if you multiply 1 with something, the value does not change. So these are the properties that you'll have to keep in your mind and remember. Okay. So now you solve some questions which are there for this tutorial and then move on to the next tutorial. So until then, take care and study well.